students, we're going to start filling out some notes on page 4 in your packet. Some of this might be some recap from the previous video, the types of reactions, but that's okay. It never hurts to hear it more than once. So let's just start talking about chemical reactions. So up until this point, we've just been talking about atoms, or we've been talking about atoms bonding with other atoms to form compounds or molecules. But now that we're getting into chemical reactions, we're going to talk about those atoms rearranging themselves from one starting point into some kind of different product. Okay, so sorry about that. All right, so there's lots of different chemical reactions around us, such as what's going on inside of our bodies in order to digest our food. When we're cooking, a lot of cooking processes involve chemical reactions, starting fires. Maybe you did a campfire recently, that would be involving a chemical reaction. Factories, a lot of those factories making different kinds of products or producing and using, different kinds of, maybe oil and gas. Those are all kinds of chemical reactions. So we talked about these signs of a chemical reaction occurring. We talked about those as we were looking at those different demonstrations. If you need to jot these down again on the top of page 4, feel free to jot those again. Remember, any time a gas or odor is being produced, that would be a sign of a chemical reaction. We're making a solid. The production of a solid is called a precipitate. We're going to talk about the solubility rules here in another video, so don't worry about that part yet. If light is being released, there's a color change or any kind of temperature change, if it's getting hotter or if it's getting colder. So here are your different chemical symbols. The arrow is going to show the direction of the reaction. Typically in our class, we're going to write that arrow left to right, and it's pointing to the products. We're going to use a plus sign to separate out reactants from each other or products from each other. These next 4 things are the states of matter. So we're going to put those behind substances in our chemical reaction. I'll show you in just a minute. And that's going to indicate the state of matter of each of those substances in the reaction. So S is solid, L is liquid, G is gas. Those are self-explanatory. AQ means aqueous, which means it's been dissolved in water. And we're going to talk more about aqueous substances when we talk about those solubility rules. If something is heated up, if we're heating up our reactants, we're going to draw a triangle to indicate that those reactants are heated up above our arrow. So here's how we would indicate those states of matter in our chemical reaction itself. So you can see that the S, L, G, and AQ are behind the substance that they're describing. And that's just letting us know what kinds of things that we're working with as our reactants and what each of our products are when we're looking at those. So when we're trying to determine our states of matter, the state of matter of your elements is going to be based off of whatever state they are at room temperature. Most elements are solids at room temperature. There's only 2 that are liquids at room temperature. Those are going to be mercury and bromine. There's some gases at room temperature. So those are going to be a lot of your nonmetals, your noble gases, hydrogen, nitrogen, oxygen, fluorine, chlorine, and then everything else is a solid. Precipitates, when you see that word, that means it's a solid product. A solid product. We are going to definitely be hearing about that word throughout the rest of the semester, so make sure you know that that means your solid product. Aqueous products are going to be present if you had something dissolved in water to start with. So if you had an aqueous reactant to start with, or if we have water somewhere present. Even if something is soluble, it can't be aqueous unless it's already been dissolved in water. And we'll talk more about that when we look at our solubility chart. So here's an example of a chemical reaction. We have magnesium plus oxygen yielding, the arrow means yielding, magnesium oxide, okay? So our reactants are going to be our starting substances, and the reactants are going to be written on the left side of the arrow, okay? You can have 1 reactant, you can have 2, 3 reactants. The products are going to be on the right side of the arrow. The arrow points to the products. And again, we can have one product, we could have two products, we could have three products, okay? If there's more products, we're gonna have separate those out with a plus sign. The arrow is yielding. It's telling us what is being produced from that chemical reaction. So in this case, we're producing magnesium oxide. And the plus signs, like I said, are gonna be used to separate your reactants from each other or products from each other. If there's a catalyst involved, and most of the time we don't really use catalysts in level chemistry, but if a catalyst is involved, we would write the catalyst, whatever it is, above the arrow, because catalysts are not part of the chemical reaction itself. They're not a reactant, they're not a product, they're just used to get the reaction to go. So in order to indicate that we're using it, we put it above the arrow, but it's not written in the reaction itself because it's not reacting. And then again, we're going to put our states of matter in our chemical reaction like this behind each of those substances to indicate the state of matter of each reactant and the state of matter of each product. Okay, so that should help us out the first part of page 4. If you have any questions, just let me know.